You notice that student scores high in science also score high in the visual art compared to math. How could you confirm that relation, and how could you use that relation in your teaching plan? Hi, Assalamualaikum. My name is Dr. Kite. In this lesson, we will learn about regression. At the end of this lesson, you will be able to construct a simple linear regression model. Alright, so suppose that you have a score, you have a table of score of 27 students in arts, math, and science. So these are the um, score for arts, for maths, and for science. So from here, we can see that every student they have three scores. Okay, so we can say that 34 and 34 for math and arts is a pad of data, so that we can create a, a point in a graph. We can plot. Once we have a pair of data, we can plot a graph. So in this case, we can plot all of this data where, for example, we assign art as variable x1, so let's say x1, and science as y. So when we transfer this data 34, 34, that means we have point 34, 34, okay, and then for example here 67, 70, so we have 27 students, meaning that we have 27 points on this graph, where it is y score in science and here score in arts, so that we have 27 points represent for each student. And then we can also make another graph for maths and science. For example, let's take this is 56, this is 53, so this is 1 point. And then let's say here we have 23 and 64, so we have another point. Then we transfer into the score of science in science versus the score in math. Okay, so these scores, this graph is called scatter diagram. You can see that the plots are scattered inside this plot. Okay, so this is scatter diagram or scatter plot. Okay, for each of the axes, they represent a variable. So it is represented by variable. Okay, so in x-axis, usually we represent it as a control variable or independent variable. For the y-axis or vertical axis, it is representing response or dependent variables. Okay, so now we have two plots of graph, scatter diagram for science versus art and science versus math. Okay, so you can see some kind of relationship or pattern. For the blue above graph, you can see that there is some cluster. That means the plot is scattered around some sort of line. And then for the second plot, it's really random. We cannot see any relation. Alright, so next we are going to use the simple model to mathematically represent the relation between variable on the vertical axis and variable in the horizontal axis. Okay, now one of the model that we can use is called a linear regression model. Here we model the graph using linear equation where y equal to mx plus c. This is normal linear relationship where the strength the strength of relation between y and x is measured by the slope of the graph. Okay, so when we make this graph, we can search for the best linear fit. So they can be calculated manually, but recently we just use Excel or any spreadsheet to calculate the linear equation for this graph. For example, I use this is Microsoft Excel. We can use the function of trend line. Okay, you can activate this function in the Microsoft Excel to calculate the best fitting where it can produce the linear equation. So y equal to 0.8 blah 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 x plus the sum of set. And then for this graph also we get another value, another relationship. And then we can also see another parameter here, r square, which is an indicator of model fit. That means how close the graph to the linear equation. Okay, so from here we can read that here the what we call it the slope is 0.87, okay, and this is 0.06. So it is really flat. You can say it's really flat. And then we can also say the relationship between y and x is really weak compared to here. And this r square also represent how linear is the relation between y and x. So this is 0.9 is very high. It's very that means it's very close to the linear fit. This is really low fit. So we can say that the score in science really can be predicted by the score in art, meaning that as the score in art for student get higher, so the possibility for them to get high score in science is also high compared to the maths. So we can predict that according to our class. So maybe different class or different school, they have different relationship. Okay, so when we put both in a same graph, that means science versus score in art or in maths, so we can see that there is a very strong relationship between score in science and the score in arts. So that means we can when you look into your school environment which have this kind of relationship, so it means that maybe your school, if the students is good in art, that means they will have a good score in science too, and it is not related how good they are in math. Okay, so this cannot be generalized for another school, but this can be your what we call study case or action research in your class, so that you can predict and you can plan well for your class or your school. Okay, so this is the end of this class. So hopefully this last topic will be useful for you as a professional teacher in the future. Okay, bye and good luck.